The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or to view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
So everyone's working on papers, I suppose. When are they due in?
They're due on Sunday.
Horrors. Well, when I went to graduate school, it was at Princeton in the math department, and there were all sorts of courses given by very good professors, because I think I've mentioned this. This is sort of 1950, and the universities in the United States were, at least the science departments, were filled with great mathematicians and physicists and people like that who had been extracted from Europe because of World War II. And the math department at Princeton was very, very, very exciting because of the, if you had a question, you had a very good chance that the world's leading authority on that subject would be in the next room or two. I was interested in the theory of knots, and there was a Professor Ralph Fox who was one of the world's experts on knot theory, and in fact he was so good at it that I gave up. Which is a nice, important thing to keep in mind. Always be ready to give up if there's someone doing something better than you, and find the right niche. But anyway, they had courses, and you would register for courses, and everyone got an A in all courses. I'm sorry, there were no grades when I got there, because Professor Lefschetz didn't like the idea of grading people, and he was head of the department, and his feeling was that if somebody wasn't doing good work, then it wasn't that person's fault. It was the fault of the admissions committee. And if anybody got through the hurdles to get there, then they were assumed to be mathematicians, and that was that. And but after a couple of years, the provost of the university got annoyed with the math department, and he sent down a message that there would have to be grades in every course. And Lefschetz said, okay. He didn't believe in fighting when there was a good alternative. The alternative was everybody got A's in every course, whether they took the course or not. And I think the end of the story is that when he retired, the new chairman wasn't as good at evading the authorities. So I have a little discomfort at grades myself, and when I gave this course in the 60s and in the 70s, everybody got an A, and it took several years for the departments to notice. Anyway, so we have to give grades, MIT. But all that's great fun. Anybody? What didn't we cover in this course that you wish we had? And I'd like to know what some of you are doing also. what's your plan to make machines smarter in the future? And how hard is it to find a job where you can do research? I haven't tried getting a new job for a long time. I just tried to hire a former student, but he's starting a huge startup. And if you can't find a job, I guess you can make one if you can fool enough investors into supporting a new operation.
I think incentives are set up so that most of the work you're going to do is designed around a very specific problem.
Design what?
Around a very specific problem. So you're addressing getting a machine to solve some particular problem, which is always, there's always a fast path to that by finding the right set of data and really finding the right model that will work reasonably well. Because it's not really like a business case that can be made for making the general intelligence in it when there's motivation to create some specific application or something.
That's right. And goes back to World War II again. The reason we could do so much in those early years about general theories was that the Defense Department had created this new wing called ARPA, Advanced Research Projects Agency. And I actually don't know what caused it to begin, but a lot of it was involved with trying to make new kinds of instruments to detect intercontinental missiles and heaven knows what else. But they decided to have a basic research branch to because if you're in the military, one of your concerns is defense. And for some reason that I don't know how to explain, but a group of people in the Office of Naval Research concluded that the best defense is to be way ahead in technology of everyone else. And since there were no particular constraints on them, they didn't have to say, you have to write a progress report every 3 months and stuff like that. Anyway, another unique thing about the situation when I started was that the students knew more than the professors about computer science. Now there were people around MIT who knew about computers, but we had the bad luck of having the best analog computers in the world, Vannevar Bush and people like that. So when things change suddenly enough, your best people might turn out to be the worst for a few years. And the leaders in innovation came from the Tech Model Railroad Club and a few institutions like that. I certainly knew something about computers, at least the theory of them, but I didn't know anything about modern programming, and either did anyone else, except Newell and Simon and Carnegie Mellon and John McCarthy, who they invented Lisp processing languages, and John McCarthy refined them and basically combined a very clumsy logo-like Lisp processing language with the algebraic language, and so Lisp came after there had been primitive Lisp processors, and all of Newell and Simon's work, including a chess program, had been done with just a programming language that had something like car, coulter, and const. So that was so it was about 10 years after the first computers at MIT came mainly from Lincoln Lab, who had the job of building supercomputers to analyze radar data and stuff like that, which were indeed connected with national defense and trying to get combined radar reports from all sorts of places to get early warnings of activities in space and so forth. When the first Sputnik was launched by the Russians, it was just a little thing going beep, beep, beep in low Earth orbit. And within a couple of hours after the Russians announced that Sputnik was there, and they announced its orbit, a couple of hackers at Lincoln Laboratory managed to track the thing by hooking a couple of it was going beep, beep, beep. And a guy named Brad Howland, who was a teenager, I think, then hooked a couple of radio receivers up with some flip-flops and things, and was able to get its exact trajectory from the Doppler shifts of anyway, then I think I've talked about that history. At some point about early 1970 or so, it's 10 or 15 years after ARPA started. Well, the big ARPA project was called Project Mac in 1963, and MIT got $3 million a year for designing and building a time-sharing system. The idea for a time-sharing system had bubbled up in a few places, but it was mainly a couple of other youngsters, John McCarthy and Edward Fredkin, who recognized that if a computer could compute thousands of operations per second, then it should be able to compute hundreds of operations per second for tens of people. And when it gets to 1 billion operations per second, then it should be able to compute 1 million operations per second for 1,000 people, and so forth. And MIT was the first place to develop time-sharing system. And as I said, they sent this $3 million a year to get that project to work. And because the guy in charge of that was a former professor of psychology named Joe Licklider, had been a friend of mine when I was an undergraduate, he added another $1 million a year and gave it to us to start the AI lab. And if that ever happens to you, I hope it will. Anyway, as I've complained a lot during the course, we were able to sort of do anything we thought was possible And we didn't worry about whether it could be done in a year or 2 or 20. We just had enough money and enough adventurous people to just start doing those things. So in the very first year, we had Jim Slagle making the program that could do integrals at the level of that students in 1801 were learning to do. I think I mentioned I made the first program that computed derivatives, and it was just 5 or 10 lines of code, because it said, it worked lexically. It said, if you see xy, replace it by the symbols x dy plus y dx, and so forth. That's how you do derivatives, where d means derivative. And since it's operating on the names of functions, then you just recurse until all the function names have disappeared. And so that was just a page of code. And then Slagle, who was blind, wrote 20 pages of code. And Joel Moses, who's, what's he now, provost or?
He was.
Did he retire or go back to work? I'm not, probably both.
Institute professor now.
Yep. And he mentioned that it took him a very long time to decode Slagle's 20 pages, because since Slagle is writing in Braille, poor Slagle has to understand his code too, and you can't just glance at a page, so he wrote this incredibly intricate, compressed stuff. And it had the weird property that it solved integrals. It did integrals at just about the same speed as good math students. So if you gave it an expression with a couple of sines and cosines and things, it might take 10 or 15 minutes. And everybody was very impressed that this computer could keep up with a human. But of course, that fact had no meaning whatever. It was just, that happened to be how slow computers were at that time. The IBM 704, which was, I guess we had a 701 and then a 704. And I think that machine was doing about 20,000 operations per second, which is probably more than a person can do, but no one knows. Well, so who has an idea on what should be done next? Yeah, what would you like to do?
A robot that would integrate, like, I don't know, maybe AI systems that would interact more with the world. And try to.
Well, we're going to need robots pretty soon. If you look at the, just for example, this aging problem, we're getting more and more people who are crippled in one way or another, handicapped, a huge population of people with mild brain disorders, of course serious ones also. And there are not enough nurses to take care of the disabled aged people. And I think that's probably going to be a major need for robotics. As I see it, the problem with robotics is that people build robots. And you look at any laboratory that has built a physical robot, and Media Lab is a perfect example of it. Or Rod Brooks had a wonderful robot called Cog, with a head and two hands. Took a lot of engineering. And there was only one of it, and it only worked for a few hours a week because it's very complicated and it breaks. And so, so the joke is that if I were starting a robotics lab, I would not permit robots. Once you simulate the robots and get them to do what you want, then you take it out of the university and hire some good mechanical engineers to make the robot you want. But you don't want to, robotics research should not involve robots. And I think I have sort of mixed feelings about the, what's the great basketball robot event called?
Basketball? You mean soccer?
Well, whatever you call it, they kick a ball and try to get, it's actually, they try to get it through to a goal. So it is soccer.
RoboCop.
Yeah, whatever. That's probably a plus for the high school students who are involved in it. But yes.
Why don't you have like robots that all like university use as like a base? Why do we keep building hardware? Like is it necessary to keep building hardware back again?
I'm not sure what's your question.
Like when we use computers, we don't build the computers back again. We use we just create software.
Yes.
Aren't we doing the same for robots? And if not, why aren't we just programming the robot to do stuff that we want?
What I'm saying is that if people program the robot, then it takes them 2 weeks to do the simplest thing. If you're programming a simulated robot, then it takes 2 minutes.
Why does it take more to program a robot?
Because the robot's broken and there's only one in the lab, and there are 8 people who want to use it, and 3/4 of the time it's down because some motor, because it's not in mass production. If you have a machine that somebody made, it's probably the first machine that person ever made. So it's no good. Look at the Honda robot called Asimo. You've all seen it, but you all saw it 10 years ago. It has not changed, but they say it doesn't fall over so often anymore.
So, like, there's a company, a French company that does a robot called Now Robot that like walks pretty good. I don't know why don't we use we buy some robots from some company?
Because they're no good. They don't do any. They've only got one elbow. They can't reach around. They don't have, you can buy a hand for $30,000 or $40,000 that has 3 or 4 fingers, but
There's probably a trade-off though between, making a more complex robot that has more interactions you can make. That gets more difficult when you're building an actual robot, but for a simulator, simulating the real environment and gravity and those sort of systems can also be difficult to create so that you're sure that whatever the reaction, so if you're programming a fake robot, you need to make sure that the environment that it's in is somewhat real, right?
well, it depends what you mean by real. It seems to me if the robot is smart and can learn and is adaptable, and when a piece of its software doesn't work, then it modifies it. In other words, if you had a higher level learning machine in the processor of the robot, then it could work in a real environment by learning that if you do this on a slippery floor, you might, maybe you should lean the other way before you. Patty Mays did a little bit of that 20 years ago. What?
Rule system that defines that moving past some threshold is going to be.
Yeah, but you see, if you have a real robot, you've only got an hour a week to debug this thing, and the program is working in real time. If you look at real robots, whereas if you're simulating a stick figure robot, then you can simulate friction and slipping, but you can move it at 100,000 operations per second, maybe. Another thing is, there's something weird about the robot people. They tell me there's so much feedback needed that they need a separate computer for each joint. I hear this everywhere. They say, it's distributed. It's really good. Well, of course, it's still falling over.
I agree that there are a lot of things about robots that can be simulated on a computer, and I agree that a lot of the things that people are currently working on with real robots would better be first done simulated. But I think that when you have a robot, especially when you have situations where it interacts with a human being, the reaction of the human being is really different depending on whether it's a simulation or a physical thing. Because I guess human beings inherently have different reactions to objects with physical embodiments. So I feel like at a certain point, especially when it interfaces with humans, such as caretaker robots, you do have to switch to the real robots.
Well, the caretaker robot has to be a smart program that's running a physical robot eventually. It's just that we don't have the smart programs, and we could have had them 25 years ago if the people wanting to make a helper robot didn't have a physical robot in their lab. Look at COG, which COG is proudly displayed in the MIT Museum. I don't know of a single fact or technique or idea that came out of that project in the decade when graduate students wrote bad theses about it.
So I guess then ultimately it's sort of like a division of labor problem where it's like, because it seems like when people are testing their code on actual robots, it's like they have too many problems at the same time. Whereas you're saying they should focus on the software, and after the software is like all good, then they can move on to like integrating the software with the hardware.
Yeah, well, the robots in Second Life were pretty good. I don't know of any people who complained that they wanted real ones. Well, you could make one because there was a language for. I don't think they did anything much, but.
Well, they don't fall over.
But I guess a good example might be well, there's Dean Kamen's robot soccer project, and Carnegie Mellon had a robot soccer project for many years, and I don't know that I've never heard of any interesting discovery that came from that. The Media Lab also, they're the nice-looking robots that smile. And people are impressed by the way that humans are attracted to these, to interact with these robots. But I think once we know that, it's something to avoid rather than to exploit. Until when the robot says, "Pleased to meet you," wouldn't it be nice if it were actually pleased to meet you? The intelligent welcome mat should be our target. Even if it doesn't move, if it just sat there and felt good about seeing you, that would be a great achievement. I don't know how you would test for it.
Have you ever played with the Pleo dinosaur?
Yes. And there was a cat that Hitachi made. In fact, we ordered a Pleo, but we never got it. Are they still in production?
I believe so. I don't know. I believe so. They seem like
They appear to be, yes.
What?
They appear to be.
Yeah, it's a beautiful job. Somebody made a cat. I'm trying to remember, another Japanese company. It was an awfully good cat. It wouldn't do much, but every now and then it would mew and sort of look at you and beg for something, but you couldn't resist it. Yeah.
So from your experience, do you know how long would it take to kind of simulate a real world to like kind of create a simulation, simple simulation of the real world?
Well, what?
And how many people? Because like you're saying that we should simulate robots in the computer and create software for that instead of creating real robots. And so we need to create a software that simulates the real world.
Mm-hmm.
But
Well,
that's very complicated for me, you know, like to have some idea, like how long would it take, and how many people, and why aren't we doing that, or why isn't there somebody doing that?
I wish somebody would explain to me why the majority of, you know, there are epidemics of ideologies, so that around 1980, the dominant idea of making machines better was to build rule-based systems. And that's probably still the most popular way to program a computer for a complicated commercial application, like making airplane reservations and keeping stock of parts in the factory and on and on. Now, when the first rule-based systems appeared, they were called production-based languages. Production is just, I think the word comes from Emil Post in the 1920s. And the idea is you have a set of symbols, X, A, Y, B, Z. Where X, Y, and Z, I meant Z. X, Y, and Z are variables, and A and B are constants. In other words, an algebraic expression, basically. And if the state of the world or the state of some process is described by this expression, then you change it into something else, like AX. So one operation might be if there's an ace anywhere, let's move it to the left. That's just a simple production. Anyway, if you read my old book on computation, there's a couple of chapters about production systems. And those were the first universal logical systems that could be applied to computers. So although there were no computers in the 1920s when Emil Post started working on that, there had been some discussion back in 1900 or so when mathematicians like Hilbert, who were interested both in applied mathematics and basic logic theories, were trying to say what kinds of processes can be represented by what kinds of algebraic or production-like systems. So there was a lot of research before, well, not a lot, but quite a bit of research before computers even appeared. And in the 1950s, making rule-based systems just out of transforming sequences of symbols became popular, and that was fine because those systems are sort of universal. However, to make a production system to play a good game of chess, there might be some point at which just making rules saying if there's a pawn here and a queen here and a bishop here, do this. Maybe you can't express things that way, and you might have to have a higher level expression, such as if two pieces are under attack at distant parts of the board, then you should decide to make a move that improves your situation in one, what do you call these? In one of these situations, and blocks a way of the opponent improving his situation on the other one. So you can't express that as a, in terms of the positions of the pieces. You have to have a higher level abstraction. And what happened in the development of rule-based systems is that you could make rules about rules, but nobody ever got very good at it, and you didn't find, and you still don't find, 6-level systems like the kind proposed in the Society of Mind book, which says whatever you do, you ought to have multiple levels, and at the 3rd or 4th level, the system should have some reflective ability so that it's keeping track of how successful it's been at something. That's a simple kind of learning. Or it's noticing that abstractions of a certain sort have been very productive in a certain kind of situation described by some other abstraction. Nobody's ever built any programs that go up 4 or 5 levels of that sort. And I suppose the reason is that nobody, virtually no one, has a job where they could definitely plan to spend 4 or 5 years. I think David here said he's, did you say 3 or 4 years to map out this animal?
That's my hope.
Oh, right, and then you should have a meta hope that you'll have such a good student or two that you'll only have to spend a year of it, and this young Richard Greenblatt or Bill Gosper or Peter Sampson will come up, and you'll notice that he's better than you at this, and that's the best thing. Mm-hmm. And then you can quit and go to a higher level.
True.
But there aren't any jobs like that. We had a lab, sub-lab that split off from the media lab that I won't mention its name, but its director got into the habit of wanting a progress report each month. Well, when we were funded by ARPA, there was something about a proposal each year, and guess what our proposal was? Anybody want to guess?
Intelligent machines?
It was what we had done. We proposed to do what we had done last year. Of course, it's nice when the head of the agency is an old buddy of yours from undergraduate years. That was Licklider, but that worked out fine. And so our proposals were, in fact, progress reports. And that way, you could do anything you want. Now, if you had to do that every month, then those proposals would look so flimsy and sick that any good executive would say, you should squash that project, it's not getting anything done. Well, I don't know how to fix that. If we try to deal with the economic collapse of the civilization that we're in, it may be politically hard to have 5 or 10-year research projects. So I have no idea what's going to happen in the next decade. Yes?
So, 2 questions. One, what do you think is the most effective format for people to make progress in AI research? Is it in universities? Would it be within corporations like what IBM is doing? Or what? And also, who do you think should be working on these problems?
Well, the problem, it looks like this, what do you call the IBM thing? Watson. That might be a good thing. It's the first substantial AI project that is trying to combine more than one method. But I don't know, I actually haven't read even what's available about it. But IBM did have AI researchers for the last there was a group in the middle 1950s. You've all read about this Dartmouth AI conference in 1954, and that had McCarthy and me from around here, and Newell and Simon, who were at Carnegie Mellon. I think it was called Carnegie Institute of Technology then, but whatever. And it had a couple of people from IBM, and it had about 6 or 7 assorted individuals from here and there. So IBM had a guy named Nat Rochester who had been involved in designing computers, and he had a lot of good ideas. And I had written on paper a geometry theorem proving program, and he started a project to actually put that on a computer. And so for a few years, IBM had a few people working on different small AI projects. Then that disappeared after about 10 or 15 years, and there was essentially no very little programming research at IBM, and they were mostly into hardware and commercial software, so forth. This Watson thing is apparently 3 or 4 years old, and it looks like a substantial project. And I'm a little worried that since they're not very academic, they might not have the idea that if you've discovered something, the first thing you should do is publish all its details so that you get credit for it. Well, it's hard. Not very many companies encourage the individuals getting credit, and it looks like the guys in that project are able to publish a substantial amount. But I think the first sign of, first good sign will be if they just dump their code out too, and let people go over it and copy it and see if there's anything there they can use. It's very rare for any AI researcher to use anyone else's code, as far as I know. It's almost never happened. I don't know. The best example, almost, was Winograd's Shrudlu program, which was exported to Carnegie Mellon and to Stanford. And both of them ran that program quite a bit. But it wasn't, I don't know why it died, but apparently Winograd himself hadn't commented enough to remember how it worked, and the beginners never got very far in improving either its robotic ability, which was non-trivial, or its linguistic ability, which was unique. It had better parsers and better semantic operations, if only for a limited blocks world. Put the big red block on top of the little green block, and it would do things like that. So it, and you could say, put the block which is on top of the big red block and do such and such with it. So it had fairly complicated ways to refer to and describe things. But it became a showpiece where you could demonstrate it, and after a few years, you couldn't even. Has anyone tried it? I haven't.
I've looked into it, but it's, I mean, it's in Maclist, so it's not even, there isn't even a clear path to run it.
So there's no interpreter to run it.
Yeah.
It should have had the whole package, of course, but because that program was big, and Maclist would have only been 2% of the whole thing. Winograd had quite a number of graduate students who finally left and did something else because the project was, they just found it too hard to understand the code. Well, who has an idea of what to do next? I bet you all have some fantasy of how to make machines smarter. You could wait for the human brain people to, yes?
I was thinking you could give more funding for science fiction writers, and then hopefully one of them will come up with a brilliant idea.
Ah, yes.
Greg Egan had a computer.
How many of you know the name of Greg Egan? Look at his web page has more exciting mathematical demonstrations than as far as I know. I don't know anything like it. Well, yes, Ken Perlin. Type Ken Perlin into your Google and get his web page, and he has, I think he must invent 2 or 3 incredibly brilliant small programs every week, because there are quite a few hundred of these gorgeous demonstrations of one principle after another. Oh dear. I didn't look ahead. Another feature of Greg Egan is that he read the Society of Mind and worked a lot of ideas that I hadn't thought of into some of his stories. So but another feature of him is that no one has ever met him. That is, if you knock on his door, which is in Perth, he won't answer. And I was discussing this with Greg Benford, and apparently there are a couple of people who have seen him, but nobody knows anyone who knows him. You could do that. Maybe that's the way to get a lot done. Make a list of all your friends and abandon them. Just think of all the free time you'll have. Are there any other Gregs? Oh, well, Greg Benford. But this isn't fair. I've lost the big chalk. Among the science fiction writers, there are only a few who actually know a lot of science. Benford is quite a good physicist and knows a lot and publishes serious physics papers. Larry Niven knew quite a bit of science, but was never a practicing one. And so in his science fiction, there are occasional technical errors, like in Ringworld. Ringworld was a big ring-shaped planet around the sun. And so here's the sun, and here's this ring. And the ring is about 8,000 miles wide and goes all the way around its sun in something like Earth's orbit, which means that it has an area of the order of 100,000 Earths. Well, Larry didn't realize that there was a bug. And if you make a ring that's rotating around a sun, well, first of all, there's no particular reason why it should rotate. But if it didn't, it would squash. But it's not gravitationally stable. So as soon as it gets slightly off center, then this part, if this is closer, it gets pulled in. And so finally, one part of it falls into the sun, and the rest follows it. So in the sequel to Ringworld, some physicist pointed this out to Larry Niven. And so now Larry Niven had little wires. I forget what they're connected to. Does anybody? They're made of something called skrith, which is 10 to the 50th times stronger than anything real, because it's pretty hard to hold a thing that massive. And so, then there are little jets, which have been built by the original inhabitants. I forgot all the geometry, but so now there's an active system for maintaining the ring world to not fall into the sun. And the sequel, this was built by some disappeared aliens millions of years ago, and the hardware is beginning to break down. So they need to find an alien race with enough engineering to fix it, and blah, blah. Anyway, Larry Niven is awfully good at making up things with a pretty good scientific background. And then when he makes a mistake, he writes a sequel to correct it. So maybe that's actually better than getting it right the first time. He has a machine, you know, the transporters in Star Trek. Niven's transporters are nice because they take out all the chemicals in your cells that shouldn't be there. So once they have transporters, automatically the people now become nearly immortal, because if you're being scanned and reconstructed by a transporter, it might as well fix all your bugs while it's at it. So anyway, there's a good idea on every page of this guy. even if it's wrong. So when I read a regular novel, which is very rare, there's usually a good idea every chapter, maybe. But I didn't write Larry Niven's name. Probably he had more ideas than any other writer, but they're not all correct. So how many of you are going to pursue AI? Or are you going to work on trying to make machines smarter? Here's one. We sure could use them. I'm sort of amused at there are a couple of transhumanist communities, whatever that means, and they're worried that the AI will, as many science fiction writers have, be hostile and take over and want everything for itself. And so there are serious discussions on how to make friendly AIs. And of course, the master of that was Isaac Asimov, who said that a robot should always put its interests beneath those of its owner or whatever. How many of you know Asimov's laws? And then there was the fourth law that he had to make, which is that it's all right to harm a human if it's to save a large number of others from being harmed. And but, you know, it's like saying we shouldn't eat meat. It's very hard to make up ethical principles that are foolproof. I'm not sure what the safe AI people have as their Asimov laws. But if you walk around the AI world today, it's hard to take seriously the idea that they might form some sort of threat. Of course, it could happen overnight, but well, we discussed the big threat the other day. Somebody making a virus that kills everything. That's the road toward nanotechnology. I can't get them to propose anything. What happens in your class, Pat? I haven't been there for a long time.
Oh, I don't know.
Yes?
Do you think efforts to augment human intelligence with machines, or rather than trying to make machines completely intelligent on its own, there are ways that we can make people more intelligent?
Mm-hmm.
Help them?
That's a great question because we're probably fairly close to the technology to do something exciting in that direction, except that we're afraid to. Because it seems to me that suppose you just wanted to do something modest like improve some person's memory. I'll bet that with a few $1 million and I don't know how many years, you could do something without understanding how the brain works to attach accessories to it. I think I mentioned Brindley's first experiment on trying to restore vision to a blind person. I think I mentioned that last time. Ley, I think. So what he did was, here's his secretary, who's blind, and here's her occipital lobe, which of the brain, and here's this area, which is the primary visual. I think it's called Area 17 for no good reason. That's the place where the signals get into the brain from the eye. Stupid, isn't it? Here's the eye, and here's the optic nerve, and then here's some other stuff, and it's all the way back here. I presume this is because we used to be an octopus or something, and the eye was here. But anyway, what's more, the wires cross and all sorts of things. But anyway, so here's this piece of brain, and what Brindley does is he makes a little gadget with 64 electrodes. And I've forgotten the details, but I think that these are actually has little coils. I believe that the thing was, there's no wire coming out of her head, but these little wires, little coils and electrodes are in, this is in the 1950s, and silicone had just appeared. And it looked pretty harmless. So there's this little pad of silicone. He has to take the bone off the back of her skull, which is risky, and so there's the gadget. And as I said, when you stimulate these, I believe 48 of them worked, and about 8 of them hurt, and about 8 of them didn't do anything. But if you fired up this one, then she described it as being like half a matchstick at arm's length. And they were little bars, which is interesting. They were not little round dots. But there were enough of them that she could read letters one at a time. And so that's the 1950s. And as far as I know, it's never been done again. Maybe, is there some way to look that up? Yes?
So they, I think, improved the memory of rats recently.
Of rats?
Yeah, and they can turn off and turn on.
Okay. Yeah. But anyway, I suspect that if you got permission to try, I'll bet you could put 1,000 electrodes maybe in a couple of places on the cortex, and just poke around, and I'll bet that you could do it without much danger, and eventually get enough inputs and outputs to hook it up to something stupid like the Oxford Dictionary, which would be about that big, and or make it a memory retrieval system where you think, I don't know what you'd think, but people having this gadget in their head for a long time with a screen producing outputs would learn how to control some of those little spots, and then another part of their brain would learn to control groups of them and so forth, and maybe after a few days or weeks or months, you'd be able to operate this as like the touch screen on your iPhone. And it would provide you with a huge, inexhaustible amount of memory and for 1 in a dozen people, it might produce outputs that get right into your mind in some graphic or auditory or unspeakably alien sense, and you'd know something that you didn't know before. So that would be a very thrilling area. And there are lots of epileptics who are having pieces of their brain removed because it's saving their life, and it would be almost risk-free to slide this little gadget in while you're at it, because now it's 60 years later, and we know which kinds of silicone implants are tolerated, and I'm sure there are other things. What substances can you put in the body that don't irritate it? Must be quite a few.
I mean, in a sense, we're sort of already doing this, like, brain augmentation thing, right? Like with our computers or with our smartphones, except for the interface
Right.
between us and the device is a lot funkier.
Mm-hmm.
This is just like more direct, whereas right now it's like we have to, like, I guess, use our bodies to actuate the machine and then, like, use our senses to get the information back into our mind.
Right, and we're being very sluggish about it. I don't see why you couldn't put little pads in the toes of your shoes so you wouldn't need a mouse.
Mm-hmm. Or they have, like, tongue interfaces where, like,
Well, yes.
tongue displays where it sort of sends, like, electric signals on your tongue in a 2D grid so that you can, like, I guess, feel like some shape. And there's also, I saw this talk last week of
Yes.
Microsoft Research working on this, like, tongue controlling interface where you can use, no, seriously, like, they gave this to disabled people and put them in this wheelchair and they could use their tongue to control the wheelchair, and it's almost like they're mind controlling it.
Yes, right. It's
I think there's actually something that does it with scanning the activity in the brain. So I saw a TED talk on it a while back.
Oh, the emotive device? I actually tried it. It's not that great.
So they look left and right, and they control which way, I don't know.
Yeah. I did an internship at a video game company and used that exact device to make a video game. And you have to train it, except for it's sort of finicky, because basically the way it works is, like, you have this training interface where they tell you to, like, push or pull, and, like, it associates, like, your certain, like, thought patterns with, like, the push or with the pull. But I don't know, it's like, maybe I just didn't practice it enough. It's not that reliable. So it's like for a video game or for, like, toy applications, it's okay, but if you actually want to use that to, like, control, I don't know, like an Evangelion style giant robot, like,
Right, it's just a proof of concept.
this is an old thing. I don't know if there are any better ones. Yes, the people with the tongue gadget claim very good results. I don't know what it's like to go around with that thing in your mouth, but
they made a wireless one. It's like in the shape of a retainer.
oh, okay. Is it anchored to the teeth or something?
It's basically like a retainer with, you know, wires to, like,
Oh, okay.
hold it on your teeth, and it sticks on the roof of your mouth.
Oh, so you just that doesn't sound so bad. Is it wireless? That would be.
Yeah.
Okay,
There
what?
was a talk by Desmi Tan from Microsoft Research, and he showed stuff about that.
This guy, I think it's spelled right, but I'm not sure, is a professor at Stanford, and he made an array of vibrators that go on your back. And I put it on once. It's 20 by 20, I think. And they all work, so it's better than the 8 by 8 thing. And I was able to recognize a telephone. It's connected to a video camera, and it's just a pad on your back. And if you have a TV camera with the right kind of contrast, and you can find the door and stuff like that. It's easy, and I recognized a couple of objects. I was only in it for about 5 minutes, but the interesting thing is that it didn't take any time to feel this input as a shape. I was pretty surprised. That was many years ago. I don't know what's happened since. There are reading devices for the blind that go on your finger. So instead of Braille, you go like this and it can make a sound, or it can make a vibration in your fingertip. See, the trouble with Braille is you have to have Braille. But this device, I can't remember who makes it. You just put this little thimble on, and it has tiny vibrators so that it's like Braille. It makes, and you can feel the letters go by as you move your finger. And I've forgotten the professor's name for this. Does that ring a bell? Anyway, only about 10% of blind people find it easy to learn to read this way. So it's not widely in production. But that's all beside the point. I think at some point, somebody's in some country will want to try this direct brain connection thing. Might be great. Might be really good for an older person who's become blind, and a senior person who's lost vision might not be able to soup up their hearing and other senses well enough or learn fast enough to get around. So if you become blind deaf like Helen Keller when you're a few months old, or was she 3 years old? Anybody remember? So she just adapted and became quite a good writer. And
I think when thinking about like augmenting human intelligence, there are really like two big realms to think about. One realm is sort of like developing the external device that like does the thing for you, that retrieves information, and then the other realm is like the interface between the external thing and the human being.
Yes, what's the representations? And it'd be wonderful to have a gadget with a bunch of brain electrodes, so you could discover what kinds of symbols can people learn to distinguish, and we'd probably learn more about the brain in a couple of years than in the previous century, because we could get some idea of representations. Do people represent things as list structures or as productions? Or computer science has come up with lots of ways to represent knowledge. I've never met a neuroscientist who even knows what the your smirk. Maybe there are some I haven't met, I'm sure.
Well, there's me. That's why I smirk.
But I've complained about this about 4 times already, but the best example is to look at the review of The Emotion Machine on the Amazon book page for it, because there's this neurologist who says, he writes all about these K-lines and penalogies and isonomes, and he has no evidence they exist. And it's just so funny, because I'm writing this book to help those. Here they're drowning in ignorance, And I've just taught them this life raft, and they say, well, he hasn't tested this life raft to see if it... They don't like the idea of a suggestion if you haven't proved it. So that is not the way to do science. You have to make hypotheses. And if you're a neuroscientist, you can't do that because it's not in your nature. So you have to get them from someone else. It's very simple. How come there are no programming languages that have decent representations of anything? People tell me they use C++, whatever that is. I think Winston wrote a book on how to program in that. And I asked him, do you actually know how to program in that language? He said, of course not, but I know how to write books on how to program. Do you remember that?
It was a great learning experience.
You actually said something like that. Because you write the book and then you can get other people to put in the examples. You should all read some of my...
I couldn't force myself to learn C without writing a book about it. It was too boring.
That's the way. Right. If you read my book on computation, which is still actually current because it's about things that they don't teach much. The best thing about the book is that it's full of problems that you can actually solve. But I wasn't good at making up problems. So most of the problems there were made up by a young graduate student named Manuel Bloom. And I don't think I gave him enough credit in the book. I just took it for granted that people are good at making up problems. And I didn't realize how rare this was. He now has the property that Manuel and his wife Lenore and his son, whose name I forgot, are all professors at CMU. So that's...
Computer science.
Yes, do you know any? Are there any other such families? But and as far as I can tell, Winston's book has been substantially replaced by this Norvig and what's his name? But there's right, but there's almost no ideas about AI in that book. So we have a textbook that is not helping the field progress very much because it's giving a lot of details about methods that I do, well, you know, like lots of stuff about probabilistic learning, which is very nice, but I don't think it has much future. So if you meet anybody who's interested in AI, get them to read Pat's book. Yes?
So what happened? Like, why did MIT change like so much? Why did like so many machine learning people?
Well, there was a very strange phenomenon called Rodney Brooks, who somehow got a worldwide reputation for inventing, what was it called? Subsumption. Subsumption was a formulation related to what the first computer people called priority interrupt. So instead of having high-level programming languages, Brooke pointed out that if you just have a bunch of statements and give them priorities, and then take the one that, you take all the statements that apply to a situation and take the one with the highest priority and do that, then you can write a PhD thesis and make a movie of an experiment in which a robot actually found a Coke bottle. Now, the fact that the first 40 times it didn't find the Coke bottle because when it got near the table, it couldn't see it anymore, and it had no memory, was ignored by the worldwide community. And so some of Rodney Brooks' ideas swept the entire world, stopped research in Japan, because they all turned toward saying, if you just observe the environment properly, you can solve a lot of problems without making plans. And he won the top prize that the AI Society gave out. It's a complete mystery to me. Here is 4 or 5 really bad ideas that swept the world and replaced almost all other AI research for a decade or two. It's wonderful. That's why there are no robots that can go into the reactors in Japan and fix things, because all the robots we have only react to. Never mind. Yeah.
So how do you see we changing that from now? Because now we have a problem that maybe most of the stuff in computer science or most of the people doing AI are doing probabilistic, I don't know, inference, or I don't know, some kind of supervised learning or unsupervised learning. And that makes a lot of money. I mean, if you...
Well, that's the problem. The best way to make money is to steal it. So why doesn't everybody just turn and go down the corner and mug someone? I mean, yeah, there's a real problem here.
Because you can mug a lot of people in parallel using algorithms.
Right. That's really... You got it.
And isn't there any like other smart professors that like why can't they see that? Why don't they see that?
It beats me. I'd like to hear some theories of why the textbook by Russell and Norwood doesn't mention the Society of Mind theories, for example. I mean, they've been out there for 30 years. So there's something, I don't know what the problem is.
But 250,000 people are taking that course.
Well, so things are going to get worse or better.
Worse.
Has anybody watched some of this course? Has it started yet?
Oh, it's almost over.
Okay. Have any of you looked? No one here?
I looked at the beginning.
I think it would have more appeal if we weren't already taking classes.
I couldn't hear.
I think it would have more appeal if we weren't already taking classes here. Most people I know who are taking that are working in industry or nursing school.
Uh-huh.
It seems to me that, for example, machine learning, when people take machine learning, they think they are very smart because they can do calculations with like a lot of symbols, and they think, oh, I'm such a genius. Like, I'm not saying that I'm smart, but like, it seems to me that dealing with symbols make people think that they are very smart, and that makes the situation even worse because you have maybe people that could solve this problem, and they are, oh, I can do like a lot of calculations. There are these really hard formulas that only I know.
Well,
it seems that theory of symbols is like more complex and harder, and people tend to stick to theories that have symbols and formulas. And
I guess so, but somehow it doesn't. To me, mathematics is really hard, and symbols are easy. It's sort of funny.
Yeah, but they're still symbols.
Yeah. Well, does the machine course ever mention, like Pat Winston's?
It's all about techniques.
Machine learning?
Yes, because what Winston does is he looks at the differences between things and gets rid of them, and you can think of it as a sort of symbolic servo. But there are a lot of very simple, common sense, sensical operations in the methods that he describes, but none of them are easy to express as equations. And maybe programming isn't technical enough, and you need to dress things up in algebra to make the.
I should redo that thesis as an energy minimization principle or something.
Yes. Oh, that's cute. Yes. Getting closer to the goal, that's all it is. I think I mentioned the Newell and Simon had this great idea of getting closer to the goal, and they gave up when they couldn't solve the missionary and cannibals problem, because there's a step where you have to take 3 people back in the boat, and their program refused to do that because it wasn't getting them closer to the goal. And the funny part is that if you used pairs of operations as the unit, then their method would work. But nice question is how do people make a very beautiful theory and then not take the next step and someone else does it N years later? It's sort of, I guess it always happens, yes.
I was just going to say, I think machine learning is incredibly useful, and we should discredit it because it really isn't AI. And I think a lot of the problems between machine learning people and AI people is that they're trying to do different things and they just have shared history and see different important problems. Because
they're not doing different things. One is doing a subset of the other.
Yes, I mean, I mostly agree that machine learning is the main problems of intelligence and cognition, but they are making a lot of good progress in solving certain types of really hard problems. And this can be really useful because a lot of these are problems that people aren't able to solve themselves and aren't good at.
Machine learning is the engineering discipline, and AI is the science.
One at a time. Yeah.
Sorry.
You could say that about anything, though. Surely what's really important is not solving all sorts of useful things, but getting to a higher level where you can solve things that no one else can solve.
Depends upon what you mean important for what? Important for the advancement of science? Yes. Important for like miscellaneous applications that are useful to people?
Well, in the long run, you're dead. So
yes, but,
things like science.
Say that everything that doesn't just advance science is completely useless is crazy.
No, I'm saying science has disappeared because the Dark Ages. It's interesting, but if you say it's just advancing science, yes, I take the position that we should spend a fraction of our world resources on long-term things. And it's no excuse, and no one should say, let's spend all our resources on immediate, useful, money-making, labor-saving processes.
I'm not saying that. I think we should spend quite a bit of money on science, but I'm saying that doesn't mean that anything that's not science is...
Yeah, but if you look at AI, no money, I only know about 10 people in the entire country who are thinking about hard problems in AI. So it is, it's not just a mild complaint. There's some kind of pathology. There's no support.
I don't think anybody's denying that machine learning is useful. It's just the problem is that it seems like the obsession with machine learning is sort of like overtaking anyone like trying to make progress in AI. So it's like, okay, in the ideal world, it's like there are the people who work on machine learning, but then there are also the people who are solving the big AI problems. But it seems like in the current world, like so many people are doing machine learning that like, and there's so many resources for it, and such that there's like not enough for people who are doing AI.
Yeah, well, my complaint is that there's almost no one doing AI. It's very peculiar. So what is it about the current culture of science and technology that causes this to happen? A great example would be, what's the gross product of, what's the income of IBM? It's a big company. How come they're doing that funny thing? I keep forgetting. How come they're doing Watson? Isn't that?
Because it's cheaper than Super Bowl ads.
Because they're getting.
No kidding, they got a lot more publicity out of it than they would have gotten if they'd spent all that money on Super Bowl ads.
Mm-hmm. I guess so. But it's a serious company. It fired its real AI group. And what? Maybe properly.
The question is, or perhaps a supplementary observation is that when we were doing stuff a long time ago, it was regarded as a great success if you could get a program to do something for the first time. And the field has been taken over by people who want to measure how much better your thing is than the next thing. And there are only a few kinds of problems that are susceptible to that kind of
scoring
comparison. As a consequence, people working on those kinds of problems are not doing things that ought to be done, like doing something for the first time.
Mm-hmm.
So it's a lot easier to write an article about how your parser is 1% better than somebody else's parser than it is to get a program to have common sense, for instance.
Yeah. Well, now there are 4 or 5 common sense research groups, I think. How many? I don't know if any of them make a living yet.
Well, they're collecting common sense. I'm not sure they have common sense.
Mm-hmm.
And you can measure how many things you know, but it's not clear that they're measuring how effective they are with the stuff that they know.
Yeah.
Maybe that's an exception.
I wonder how hard it would be to make a program that knows mathematics, and a lot of mathematics, and does the kinds of things that mathematicians do. But somebody would have to pay them to do it, and that's where do you get support for common sense in mathematical reasoning? It's a beautiful subject.
Well, there was Lead, and there was Maxima, and there was Slagle, and there was Moses.
Mm-hmm.
So there are lots of
And right, and Wolfram. It might be, for all his faults, Wolfram's going to get people to work on real AI, because he's hired some people to try to make, what's it called? Wolfram Alpha, it's called, to make it have more and more common sense. Yeah.
I also think one of the big challenge is to trying to make systems that want to do math or things that mathematicians do is deciding what problems are interesting and what wants to work on. Because there is automatic proof verification and proving, although those are also rather difficult problems. And when you get to complicated things, they don't seem to work out as well. But what should be proven is something that I've never seen tackled and doesn't seem really all that feasible at the moment.
Well, Doug Lennett's first piece of work was on a thesis that did a kind of mathematical exploration on the basis of some theory of why a piece of math, why an expression or a transformation might be interesting. So even that had some precedent.
Oh, really?
It was a system that started from scratch and proved a few theorems and looked around for things that were interesting and invented the opposite of least common divisor or something like that.
Yeah, that was AM.
Yeah.
And it was pretty exciting, and that's something that anybody could take up again any time, and be a great thesis topic. Lennett, the phenomenon in AM was that it discovered division and prime numbers and a number. I think I talked about it. And as Pat says, it had a bunch of criterion for interestingness, and it would find, sets that were unusually large or unusually small, and try to make more things like them and that sort of thing. But it's never been followed up. And
we could make a program to solve like high school Olympiad math problem.
Yeah, high school algebra is a wonderful area. And there was Bobro's thesis, which did a little bit of it. And I've never seen. Now there's so much more known about natural language. You'd think somebody would do a super Bobro program that might actually be good enough to connect into Google so that it would solve problems that real people faced every now and then. So, yeah, the appearance of the new Siri and Dragon things, which actually answer useful questions, and Wolfram Alpha, might change. There might be an industry in common sense AI that's actually useful because a few million people might start using it as soon as it gets just a little bit better. And I find that Dragon and Siri, I haven't used Siri, but Dragon now has a thing called Dragon Search. You talk to it and ask a question in ordinary English, and it goes to the web and makes a Google search sentence out of what you said. And a good fraction of the time, it saves you a half hour of search.
None of those really have any idea of context, though. Like a very simple improvement would be, and Wolfram Alpha already does this a little bit, is to say, assuming that you meant X, did you mean Y or Z, and you can click those instead? And that's as far as the conversation with Wolfram Alpha goes.
Right, but you're a person, and if it had a lot of information about you, you could collect. First of all, it would say, what kind of person are you? And you'd give your biography. And maybe we'll get common sense databases that say, well, here are the kinds of things that somebody who likes pole vaulting is likely to know.
We already have the what kind of person are you databases in social networks. That's what it is, right?
Mm-hmm.
For Google's personalized search. Yeah.
Well, I just joined Facebook by mistake. And all sorts of people want to link. And all you have to do is look at their biography and see what music they like. And you can see you don't want to have that person as a friend. But I wish, has anybody written a program to automate this? I could tell them I don't like music written in the last 20 years. And that would get rid of about half of them right off. Of course, there might be Freeman Dyson or somebody who happens to like one of these tunes. But I don't know. So then you have to make a hierarchy. If the person happens to be a really good physicist, then we'll flush that particular filter.
Yeah, also Google's personalized search profile thinks that I'm a man because apparently I've searched too many computer science things in the past.
That's pretty good. Maybe thinks most people are a man.
Oh, I don't know. Like with other women, they get it right. But like if you happen to be, you know, a woman who does computer tech-ish stuff, and if you happen to do a lot of search on like programming, for instance, like looking up APIs of things, then it tends to try to think that you're a man.
Mm-hmm. Does it store the gender as a Boolean, or is it?
Oh, I remember. I saw this like a while ago, and it was just like, according to this, here's what they think that you are, and at the top it was like, we think you're a man.
I'm interested to know though, like how manly exactly you become for doing stuff.
Yeah.
So I don't think they actually tell you like their internal representation of who you are, but you just get to see like a couple categories, like male 25 to 35, interested in computers, interested in etc. I'm sure they keep it as they float somewhere, but.
You could cross-correlate that with geography and be like, this is the manliness level in a certain...
Is there anything in Facebook that would help us get a common sense database? Or is it...
There's no common sense.
Or is there no useful knowledge?
No, there's not.
Must be something that...
Well, apparently a few years back for Hal Eggleston's class, somebody made a program that could find out who was gay or not, even if they don't put gay or not gay on their profile, like based on who their friends are.
Yeah, my friend was gay, but he found out.
Well, see, this is why
I mean, that's just statistical correlation.
Is actually useful because you can specify that you're looking for someone who is 0.75 female.
How many women's names begin with the letter X?
Begin with?
The letter X. That may be your problem.
Yes, it could be. I heard that China is allowing more names.
Is allowing?
Well, I read an article which said there are only about 100 names in most of China. And in fact, there was a law that both your names have to be from this small set. And so there are only 10,000 different pairs of names. Do I mean that? Yeah.
Family names?
Are there a lot of family names?
Well, I feel like there aren't really restrictions for names as long as they're Chinese characters, right? I heard about like a lawsuit in China where somebody wanted to name their kid something.com and the government. But as long as you pick, you know, like real Chinese characters, you can name your kid like Big Poopy Head and it's okay. In fact, naming your kid Big Poopy Head is actually rather common in the countryside because there's some superstition that believes that if your kid has a really terrible name, then he won't die during childhood because even the devil won't want him.
And for all we know, it's true.
Couple says knowledge. Are you only allowed one first and last name though? Because it seems like you should only need 2 names and then just give everyone at most 64 names and that should cover all
Well,
of
so
China,
I
right?
think in Chinese it's like, there's a set of last names that's pretty much standard. And I'm not sure how many, maybe a few hundred. And then given names, so family names are usually 1 character, but occasionally they're 2 characters. And given names are either 1 or 2 characters.
And you just get those 2.
And you can pick any character.
Oh, well, there are a lot of characters,
Yeah,
like several thousand.
yeah.
But so it's something like 1,000 by 1,000 or 3,000 by 3,000 by maybe another 3,000. The British solution is to just keep adding simple names. Like my brother's name is Dylan Neville Thomas Bedford. And you can just keep changing the names, and then if you get stuck with too many John Smiths, you just do 3rds, 4ths, 5ths.
Well, the article I read must have been wrong then, or I misunderstood it. Because it said somewhere areas of China there are only 100 names. So if you have more than 10,000 people, you get people with the same name. And anyway, that's their problem.
Maybe the person who wrote the article couldn't tell the difference between their friend's shoe and their friend's shoe.
Well, one thing that they also did historically in China is that sometimes people have middle names, and the middle names is based on this thing that was like written centuries ago, that for each generation it has a set character that must be your middle name. So your name will be like family name, this middle name, and then your actual given name. So I don't know, maybe that, but that's sort of like becoming more obsolete nowadays.
Well, in English, we have lots of names like farmer and painter and so forth. But people don't live up to them much.
Because it's difficult to tell what a given baby is going to do.
But you can order it around.
But actually, the historic Chinese system is kind of an interesting way of addressing people, like indexing people, because you have the first character, which is the family, and then the second character is the generation, and then the third character is you. So it's like, you know, if your family is X and you're from generation A, then your siblings will be like XAA, or XAB, XAC, whatever. And then like the next generation will be like XB, whatever. Okay, maybe I should have picked different alphabet sets, but you know what I mean.
Oh, a generation number? Like
Kind of, except for it's a character.
There should be enough IPv6 addresses.
I feel like you're just going to end up with us all being numbers. So, that being said, I've always wanted to name my kids something that rhymed with the letter like 1, 2, 3, 4, so that like I can just call them by their number without them realizing that I'm calling them by their number.
That's good, great idea. Yeah.
I think Juan is a
Perfectly good name.
It could be the number of letters in the name, like 4.
You name your 4th kid Forrest.
4, come here.
Or name your third kid Trey.
Eventually the name could be longer and it could be a whole little semantic net with little list structure in it. And there was a nice science fiction story about some culture where you had to know your genealogy back hundreds of generations. I forgot the author, but it was made into a movie. Well, who wants the last word?
Dusk.
Someone else can have it.
Yeah, do we have any announcement to make?
No, just final projects are due on Sunday. That's it.
Do you know what you're teaching next semester?
We're trying to make a plan for some kind of weekly seminar that's not for credit. Although I might have to make it for credit for financial reasons or nobody will pay me. But we could go back to giving everyone A's again.
So you won't be teaching this subject until next fall then?
I guess not. I haven't absolutely decided, but I'm pretty sure. Can they take your class? How many students do you have each year?
Well, we've got room for about 40, and usually about 120 sign up.
Mm-hmm. And then you weed them out?
Yes.
I'd like to borrow your weeding program. Okay, well, thank you all for coming, and it's been fun.